This is a video on the ideal gas law. I'm just going to do two problems on here. It's out your notes. Again, the ideal gas law is based on this. We've been doing P times V over T. Well, moles would be down here also. This ratio never changes for a gas. Okay, if temperature goes up, the pressure and volume go up with it. If moles go up, one of these has to increase as well. So those things go hand in hand. And they always equal R. R is 0.0821. Okay, this number right here. So that's been shown to you, I believe, in class. Usually we write this as PV equals nRT. Just a little bit easier to solve when it's written in that manner. Okay, so here's the two questions in there. You have 32 grams of CH4. Okay, we're going to need to turn that into moles. Okay, that's not moles, it's in grams. So let's do that right now. 32 grams CH4. For CH4, 16 grams is a mole. That gives us 2 moles. Here's our pressure in atmospheres. Always has to be in atmospheres, so this next one is not in atmospheres. We'll have to change into that. Temperature has to be in Kelvin, so we need to add 273 to the 55. And it's asking for the volume of gas, which will be in liters. Okay, volume is always in liters. So again, as we're doing this is always 0.0821. Pressure always has to be in atmospheres. Volume is in liters and is moles. Temperature has to be in Kelvin. Okay, the reason those have to be in those things is because this value right here is in those values. So plug our numbers in. PV equals nRT. Our pressure is 5.6. It's in atmosphere, so we're good to go there. So we go 5.6 times V. V is what we're trying to find, the volume. Equals N, which is 2 moles. Times R, which is 0.0821. Times our temperature, which is 55 degrees Celsius, but we need to add 273 to that. So 55 plus 273 is 328 degrees Kelvin. So the time you use this is when you're not at STP. Okay, if we're at STP, we know that every mole is 22.4 liters. When we're not at STP, at different temperature and pressure, we got to use this to figure these things out. Okay, so a little bit different situation. To get an answer to this, you're going to multiply these 3 numbers and divide by 5.6. Again, you're trying to get V by itself, so multiply here. You're going to divide both sides by 5.6 to get our volume. And we do that, get a volume of 9.6 liters. There's one problem. Second one, again, you only use PV/nRT when you're not at STP. I guess you could use it at STP also. You could always use this equation, but when you're at STP, you can use the 1 mole equals 22.4 liters and figure out things. So this one, you have an unknown quantity of gas. We don't know what gas it is. Okay. Pressure is 800 millimeters of mercury, but that has to be in atmosphere. So 800 we need to divide by 760, because 760 is millimeters of mercury in an atmosphere. A lot of times I'll just put that in the equation that way, but if we do 800 divided by 760, it is 1.05. So there's our pressure. 31 liters, that's our volume. And temperature is 87 degrees Celsius. Again, that has to be in Kelvin, so we got to add 273 to that. So we plug our numbers in. We're solving for moles. Okay, pressure is 1.05. Our volume is 31 liters. That's a lot, so we're probably going to have quite a few moles. There's N. R is 0.0821. And our temperature, 87 plus 273, is 360 degrees Kelvin. So if we're doing this, we're going to multiply these two numbers. Okay, 1.05 times 31 which is 32.55. 0.0821 times 360 is 29.6. So we have 29.6 times n. Again, we're trying to get n by itself, so we're going to divide both sides by 29.6. Divide by 29.6. And we can get our number of moles. 1.1 moles. I was thinking it'd be a little bit more than that, but remember 22.4 liters is a mole at STP. Okay, we're at a different temperature, pretty close to 1 mole. Now, if it asked you the number of grams this was, you could multiply the periodic table by the mass of that in grams if you knew what the gas was. You can do the rest of the problems, hopefully. Have a good day.